And welcome to part 3. My name is Gregory Carlson, and we have 2 to go, so let's just get through it. These are both simple interest formulas, and I know this is kind of hard to read, but remember you can download these notes in the description down below. But it says PRTI, so is there a formula we have that relates PRT and I? Let's read it. It says Ralph Chase plans to sell a piece of property for $170,000. He wants the money to be paid off in 2 ways, a short-term note at 11% and a long-term note at 9% interest. Find the amount, you should underline that, that's the number we're trying to figure out, of each note if the total annual interest paid is 17,100. So that sounds like it could be really bad, but it's actually not so bad. What's happening here is we have 2 amounts being invested. So we're going to have an interest amount, and we are going to have 2 things being invested with just simple interest. And so in other words, the formula you remember from previous ones is PRT. So it's PRT, I equals PRT of the first investment plus PRT of the second investment. And so that's going to be our formula that we're going to use to figure this out. And luckily the problem tells us almost all of these numbers. So the principal rate time of the first investment plus the principal rate time of the second investment will give us our total interest. In fact, they tell us what our total interest is. It's 17,100. So we can write that number right here. Now I'm going to leave the principal blank for a second because that's a little tricky. Now the first rate was 11%, so we do 0.11. And it says he wants the money to be paid off in 2 ways. Find the amount. Oh, and look over here. They tell us the time is just 1 year. So that time is just going to be 1, so that's nice of them. Now I'm going to leave principal blank again. The rate of the second one was 0.09, and the time of that is 1 year, so that's nice. Excuse me, so I've got these 2 empty principals. So we want to know how much did he invest in each one. So this first one is going to just be X. That's fine. We can just call it X. That's the amount he put in the first one. But how much then did he put in the second one? Well, he had 170,000 to invest total. That's how much he had, 170,000. And so would it make sense that this amount should be whatever 170,000 minus this number should be? Like if he invested $1 here, then that means this would be 169,999 because these 2 numbers need to add up to 170,000, the amount that he invested. So the correct number to put here is 170,000 minus X. And I know that they tell you that right here, but I wanted you to understand where this 170,000 minus X came from. It came from the fact that the amount of money he was investing was equal to 170,000. And so therefore we could subtract this over minus the X, or P in that case, minus it to get that. So let's solve this equation for X. Left side is easy. This is just going to be 0.11X plus, let's clean this up a bit, it'll be 170,000 minus X times 0.09. So as you can imagine, we're going to do the distributive property right here. So 17100 equals 0.11x plus, let's do it, 0.09 times 170,000, 15300 minus 0.09x. So we're almost done. Let's combine like terms. The x's combined, so 17100 is equal to 0.02x plus 15,300. And hopefully by now you've done enough equation practice that this part's just autopilot. We want to get x by itself, so let's subtract the 15,300 on both sides. So that's going to be on the right side. I have 0.02x is equal to 17100 minus 15300, which is equal to 1800, and then divide both sides by 0.02. So divide by 0.02 will give us that he invested 90,000 in one of them. So because we know that the amounts have to add up to 170,000, I can just do 170,000 minus this number to get the amount he invested in the other one. Minus, and we get 80,000. However, let's be careful. Which one goes with which? So does the 90,000, is that the 11% amount or is that the 9% amount? And the answer is it's the first one, because remember x equals this number, and so that's the amount he put in the 11% account, because that's what we called x. This 170,000 minus x, that's the number, the 80,000, that would be in the 9% account. So let's do one more. We have a similar problem, so let's do it quickly. Planning her retirement, Lisa deposits some money at 3% with twice as much deposited at 4%. Find the amount deposited if the total interest income is $1,650. So once again, our formula is, this is just simple interest. So we have the first account plus the second account. Okie dokie. Now again, we're just going to assume here that the amount of years is 1 because they didn't tell us otherwise. So her total interest income was $1,650. So we want to find out, I'm going to leave the principal blank again because it can be tricky. The interest rate of the first one was 0.03, and we're assuming that t is equal to 1. Let's leave the principal blank for the second one. The interest rate for the second one was 4, and we'll assume that this time is equal to 1. So Lisa, you should have been prepping a little bit earlier for your retirement, I think. This is not planning for your retirement for 1 year is probably not the best strategy. But let's see how much she invested. So what goes in here and here? So last time we had an amount and then 170,000 minus an amount. This one's going to be a little bit different because look, she deposits some money at 3% interest. So let's call that X because I don't know how much she put at 3%. And then it says she put twice as much at 4%. So what do you think goes here? She put some money in here and twice as much right here. What number should go here? Can you get it? The answer should be 2x. Because if she put some money here at 3% and twice as much at 4%, that should be a 2x right there. After that, it's just all downhill to find what x is. So that simplifies to 0.03x. 2 times 0.04 is 0.08. And so that means we're going to get 1650 equals, add like terms, 0.03 plus 0.08 is 0.11, then just divide by 0.11. So x is equal to 1650, 1650 divided by 0.11. So the amount she invested in the first account was 15,000. Remember, I know that it's in the first account because that was the X. In fact, she's asking what is the total amount of money that she invested. So this number we know is a 15,000. So what number do you think the second account is going to be? So the first principal was 15,000, and the second principal is going to be double that. So 15,000 doubled, which is 30,000. So that means she invested a total of those amounts added together. So she invested $45,000. She got some pretty good interest rates and got $1,650 of interest out of that investment. So those are a few types of different word problems that you might need to know how to solve. I know each one is a little bit different and they have different strategies, but I promise in class when we practice this, and if you keep practicing on your own, that you will get the hang of it and that you will be able to solve these. For each one of these problems, I started with the initial equation, then tried to find out how to substitute the values so that I could work to an equation that just had one variable. Also keep in mind that it's always a good idea to draw a picture if you can, and that can help you get you on the right track with geometry problems. Alright, that is section 1.2, and I hope you have a great day.